about anything we have learned. Anything. So don't automatically jump into homework and start copying down what we did on the notes. Actually read the question and what it's asking you to do so that you get your full credit. Because if you're not going to do the work like I ask it to be, then I'm not going to give you full credit for that question. Will I give you some credit? Yes. Will I give you full credit? No, because you didn't follow directions. Okay, so step one, put our name. Blue or red, up to you. I'm feeling red today. Put our period. Okay. So it's not always going to be completely identical to the notes. Do not assume it's going to be completely identical to the notes. Read the question. Look at any notes we've given about it. All right, so this one, this isn't even chapter 5. We did this way before. We did this reviewing. So I'm trying to figure out why there's a couple people with the notes not open. That needs to be handled. So looking at it, what do we have to do first? What's our step one in a problem like this? What's our step one in a problem like this? Yes, the distributive property. So with the distributive property in mind, how do I show I'm doing distributive property? How do I show that? Yep, the lines. So let's go get the distributive property lines in. Okay. We're going to do our lines. So we're showing our distribution. Oops, I got to fix that. I forgot I left it in the other mode. First, blue or red, right? And then we got to make this a 1. Okay. So we make the lines. Then we show the distribution math-wise, right? In math version. What's the next line going to say to show the distribution in math version? Yes, that we're going to show that that 3 is going to multiply times each piece. So 3 times the 2x plus 3 times the -1 plus the 7 that was already there equals -44, right? We good with that? That's something we've done before, right? Okay, so what would we do now? What would we do now? Come on, guys. What would we do now? Yep, a parentheses. We're going to solve the math. So someone other than Brian. What are we going to say? Yep, that it would be 6x minus the 3 plus the 7 equals the negative 44, right? All right. Are we ready to do our balance beam, or do we still have some cleanup to do? Are we ready to do our balance beam, or do we still have some cleanup to do? Are both sides as simple as they can get? Are both sides as simple as they can get? No. We have to handle this cleanup, right? And it's not necessarily adding, it's just we have to do cleanup. We're combining, because sometimes it might be subtraction. It's just there's more than one of the same thing on the same side. So we can't be doing both side stuff yet. We can't do the +3 to both sides yet. We need to pull together the left side so it's as simple as we can get it. So if I pull together what I highlighted, the things that needed to be pulled together, -3 plus a 7 would clean up that side to be what? 4. So +4 or -4? +4. And that's going to equal the -44. Okay, so we can't be doing the both side stuff until we have each side as clean as we can get it. Okay, each side as clean as we can get it. All right, any questions on that? Okay, so are we ready for the balance beam? Okay, so let's put our balance beam in. Balance beam. What's my first step on the balance beam going to be for this problem? What's going to be the first thing we do for this problem? Yep, we're going to subtract the 4 from both sides. Okay, we're going to subtract 4 from both sides. Okay, so -4 from the left. Whatever we do on the left, we have to copy and do on the right. Okay. -4 plus 4, big 0, all gone. So what's it going to clean up to now? What's going to clean up to now? Mm -hmm. 6x equals -48, because that's all that's left after we cancel that side. And then we do the math. Negative plus negative is just a bigger negative, -48, because they're same side. Have we handled all our big zeros? Okay, so then we're going to move on to our ones, right? So if we move on to our big ones, what are we going to do? What am I going to highlight? What needs to move and how? What needs to move and how? Mm. So we have to divide both sides by 6 because we don't want the 6, not the 6x, the 6. Okay, we need to move the number away from the letters. Okay, all right, so I'm going to divide both sides by the 6. So 6x divided by 6 is going to equal the negative 48 divided by the 6. We know that 6 divided by 6 makes 1, so it's unimportant. It big 1'd out of there. And we are ready for a final answer. What is our final answer to this? X equals negative 8. Okay. All right. Okay, so is this one drastically different? No, it just has 2 parentheses. The process is the same, right? We have to show our distribution for both of them. Okay. Now what's in front of that second parentheses really, truly, that we don't see but we know is there? -1. That's right. I see a negative sign and there's no number, so it's -1. All right. So I have my 6 times my 2x. It's a positive 6 times the -5. And that's got to equal the -1 times the x and the -1 times the +4. Okay. So now we're going to do the math. What's the math come out to be? What's the math come out to? Do the math. What are we going to get? Do the math. What are we going to get? Remember, you need to have your eyes showing. We know better. Yep, 12x minus 30 equals negative 1x minus 4. Okay. Now, while we're in the problem, oops, it's okay to say the negative 1x. But when we get down to the final answer, we're not going to have the 1 in there. We'll just have the negative if that's what's going to be left. But as you work the problem, to say negative 1, that's fine. To remind you that it's really a negative 1 there. Okay? So, are both sides as clean as they can be? Are both sides as clean as they can be? Do I have two numbers or anything like that? Yeah, so it's as clean as it can be. So we're going to put our balance beam in. Oops, I forgot it was a 0, but I can go like that. Okay. So now we're going to go do our big zeros and our big ones. What are we going to do first for this problem? What would be our first thing we have to look at? When we go to do the problems, where do we look first? Letters or numbers? Letters. And what letters are we going to move first? What letter? The negative 1x. And so how are we going to get that negative 1x out of there? Because it's smaller, we want to move it by doing the opposite. So we're going to be adding 1x to both sides. Yeah. Adding 1x to the 12x's. And whatever we do on the left, we copy and do on the right. Okay. That makes the negative 1x 0, and we don't care anymore. And cleaning up the left-hand side, what's it going to say now? Cleaning up the left side, what are we going to do now? Yep. Exactly. So we now have 13x minus 30 equaling negative 4. Right? Okay. Have we handled all our big ones? What do we need to handle now? Gauge, camera, numbers. So let's go look at our numbers that we have to work with. We have this negative 30 and the negative 4. Now, do we use the same rule for the numbers as we do for the letters that the big one moves? Do we do the same rule for the numbers as we do for the letters? Move the smaller one? No, we don't do the same thing for the letter numbers as we do for the letters. What do we do for the numbers? what number would we be moving with our big 0? So not division. Okay, yeah, we got to get rid of the number that's all by itself, but it's on the same side with the x, because that number that's on the same side as the x that's adding and subtracting is getting in our way. So we need to get rid of the number that's adding and subtracting, but on the same side with the x, which is why we're going to add the 30 to both sides. Okay, so numbers don't work the same as letters. Numbers, it's move it away from the x. Letters, smallest move. Okay, numbers, move away from x. Letters, smallest moves. Okay, okay, so that creates 30 minus 30. That's 0. We don't care anymore. Clean us up. What would we have? What would we have? Yes, 13x equals 26. Thank you. Okay, so 13x equals 26. Now, have we handled all our big zeros? Are we done with the addition and subtraction now? Are we done with the addition and subtraction now? Yes. Okay, so if we're done with the addition and subtraction now, what are we going to do now then? The big one. Okay, so what's our target for the big one? Who needs to move for the big one? Our target for the big one is the 13. Why? What's so big about that 13? Why do we want it gone? Why do we want it gone? Stop messing with your cameras, guys. You know better. We need the XL by itself. So what are we going to do to get that 13 out of there? Yes, divide 13 on both sides. Okay, so I'm going to go divide my 13 on both sides. So 13x divided by 13 is going to equal 26 divided by 13. Because whatever we do on one side, we have to balance onto the other. That makes the big one. And our final answer ends up being x equals 2. Okay. Okay. What's the next one? Solve for y. What does that mean? What does it mean to solve for y? What does that mean to solve for y? Get the y by itself. Okay. Okay. So we need that y by itself. So I'm going to highlight the y because he's our target. We need to get the y all by itself. The y has to be by itself. We'll undo that. I just did the wrong thing. Not the number, the y. Okay, so we need to start looking at what needs to go. First thing, just like before, we have to handle our big zeros and our big ones, okay? We're doing the same thing. We're handling our big zeros, we're handling our big ones, all right? It's just, we're not gonna come up with a number answer. We're gonna come up with a rearranged equation, all right? We're not gonna come up with a number answer. We're just gonna come up with a rearranged equation. So we have to handle addition and subtraction first. We have to handle getting things away from the y. So what needs to move if we need it away from the y? Because it doesn't have a y on it. Yeah, we have to get this 2x out of there. So what are we going to do to get that 2x big zeroed out of there? What are we going to do to that 2x to make it a 0, to big zero it and get it out of there? Subtract 2x from both sides, yeah. But don't put it under the 10. Great. You remembered, Brian, because it's not part of the 10. It's an x. Okay, so when you go to do this, we put our minus 2x under the 2x. That makes sense because those are the same thing, right? That minus 2x is the same as the 2x. But when I go to copy it, the other side does not have an x. So do not put it under the 10 because it's not an x. The 10 is not an x. It's something different. Okay, so be careful not to line that up. Good remembering, Brian. Okay, that means that the 2x minus the 2x is now 0, right? It's gone. What's left on the left-hand side, now that that 2x is gone? Yes, 5y equals negative 2x positive 10. Remember? Because what's our format has to be? Y equals mx plus b. Okay? So I know I stuck it down here at the end. It's because there was no space. When I go to write it, y equals mx plus b. All right? Okay, what's our next step? Have we handled all the addition and subtraction away from the y? Have we gotten the y so there's no addition and subtraction left? Have we gotten the side with the y? No, okay, so then we have to big one. We have to get this 5 out of here now with the big one. So what am I going to do to get that 5 out of there with the big one? Same thing we did before with the big one. What did we do? How does the big one work? Divide all pieces by 5, okay? All pieces individually by 5. So my 5y divides by 5, okay? My negative 2x divides by 5. My positive 10 divides by 5. All pieces divide by 5. And we have to clean up all pieces individually, okay? So the 5s are gone, big 1, no longer needed. Okay. We only have y, and then we're going to clean up the other side individually. Push the x off. Shouldn't really be there. Solve the 10 divided by 5. What do we get? So when we go and rearrange it for the y alone, we end up with the y equals mx plus b of y equals negative 2/5 times x plus 2. Okay. This one says solve for x. Process is the same, right? Sort of. What do we notice we have to do first? What do we notice this guy has before we could start getting the x alone? What do we notice that we need to do first before we can start getting the x all by itself? Distributive property, exactly. Let's go get this distributive property done. So the 3 times the x, positive 3 times the positive 2 is going to equal a y that's subtracting 6, right? Okay, clean up our left-hand side. What are we going to get? What's it going to say? Do the multiplication. Handle the parentheses. What's it going to say? What's it going to say? Yes, it's going to say 3x plus 6 equals y minus 6. Exactly. Nice. So 3x plus 6 is going to equal a y minus a 6. And we look at the instructions, and what did they want alone? What did they want alone? This time they want the x. So they want us to get this x all by itself. So what do I need to do to start moving stuff away from that x? Put our balance beam in, right? Yes, we have to go ahead and big zero this positive 6. And to big zero the positive 6, we're subtracting 6 from both sides. Minus 6 from the left, minus 6 from the right. Yeah. Okay. Big zeroed. What's the left say now? (3x) and the right says y minus 12. Because 6 with negative 6 and negative 6, negative 12, right? Is our target letter fully alone? Is our target letter fully alone? Because our target letter is this x right here, right? Is it all by itself? No. What do we need to do to make it all by itself? We have to get out of there the 3 to all pieces, right? So what are we going to do to get that 3 out of there to all pieces? Divide all pieces by 3. Yes, 3x divided by 3 has to, oops, arrow, has to equal the y divided by the 3, arrow, minus the 12 divided by the 3. All pieces, get that divide by 3 individually. Okay? So, x is alone, right? Okay, so I just have an x, and then I got to go look what's the other side say, right? Just like up here, remember we had a 2x on the top, but we pushed the x off. right? We need to push what's in front of the y off. We need to push the y off and leave behind what's in front. What's in front of that y that we know is there? The 1. So if we push the y off, it says 1/3 y. Okay? So you're pushing the y off and leaving the number behind. And then what am I going to say now? How's it going to end? With the negative 12 divided by 3 equaling what? Negative 4. Okay? So when you have your numbers and the letters on top and you're dividing, okay, you need to push the letter off. And to do that, you leave behind the number, okay? And it happened that this was a 1y. That's why we have a 1 left behind. Are we okay with that? Do we get it? Okay. Back up to the top because that one's done. Those 2, 3, 4. 4 done. Yay. Let's look at this other side. Oh, to tiles. We haven't done the tiles in a little bit. We haven't done the tiles in a little bit. That's nice. Okay, so let's look at what we have to work with, right? Okay, it says examine the tile pattern. I think it should say below, right? Because this is below, not at the right. Then complete parts A, B, and C. Okay, so we've done these before. We need to draw figure 1. But before we can draw figure 1, we have to start figuring out some pieces, right? We did this before. So we need to figure out the pieces like how much is it growing? How many do I already have? Where am I adding things on and all that, right? Because we did this a while ago. All right, so with that in mind, we need to start small. Let's start with how many tiles are in figure 2? How many tiles are in figure 2? 7, okay. How many tiles are in figure 3? I don't think it's 12 for some reason. But oh yeah, no, it's okay. 12. How about the next one? 19. All right. Are we sure? Let's see. 1, 2, 3, 4 by 4. Yep. That's a 3 by 3. That's a 2 by 2. All right. So we got to look to see what was happening, right? What was happening to go from figure 2 to figure 3? What did they do? What did they change? Where did they add stuff? Remember we had these conversations before? So we went from figure 2 to figure 3. How many did they add in? Where did they add them in? What kind of things changed up? So how many did they add in from figure 2 to figure 3? Let's start there. 5. How did the look change from figure 2 to figure 3? What did they do? They added in 5, but where? How did they make things a little different? How did the look change? What changed in the look? This is figure 2, and what do we notice about the box? So what are we noticing about this box? It's 4 boxes, but it's figure 2. So how did they get the 4 boxes? What did they do to make that 4 boxes? How high and how wide? So how did they get those 4 boxes? How high, how wide? 2 by 2. 2 by, no, not 2x. 2, and then remember the times symbols over in here in this little divide thing. Times 2, right? Okay, so do the same thing for this next one. What are we going to say? So now we're looking at this box. How did they make it? What did they do? Yep, and I'm just going to copy this 2 by 2 one and change it for 3 by 3. Right? But it's a 3 by 3. Right? Are we okay so far? So if we do it again for the box, right? How did they make it? It's a 4 by 4. Now, figure 2, 2 by 2. Figure 3, 3 by 3. Figure 4, 4 by 4, right? So if they want us to draw figure 1, is the bottom changing at all? No. So they all have those 3 boxes on the bottom. So let's start with that. Let's go get our 3 boxes. So to get our 3 boxes, we go to shapes, we go to box, we pick either red or blue. I don't care which. I'm gonna go with red. And they want us to do 3 boxes on the bottom. So 1, scooch over so that the line of the plus sign touches the before. 2, scooch over. 3. I don't like that last one. He went up a little bit. Okay, the hardest part is the scooch over so you don't go crooked. I'll get it. This is why I like the graph paper, because we could fill in the boxes of the graph paper, right? Oh, that would work. Yay! Okay, so if this is figure 1, so let's label it. Figure, oops, that's not the labeling. That's the labeling. Figure 1, right? And if we use the logic we had before, what should our box thing look like for figure 1? A 1 by 1, exactly. So let's go get our 1. Now I'm going to go up and do the corner. So I'm going to go up a little there. It worked. How many tiles are in figure 1? 4. Okay. And if we continue the logic for figure 5, I'm going to copy and paste this guy because he started, right? And to do that, we go select and we go box. And we highlight what we want, which we actually want all of this information, right? Try again, highlight what we want. We're going to copy, we're going to paste, and we're going to move it to where we need it. Now we're going to need it lower, right? Because what's the big box going to look like up here? What's this one have to be? For figure 5, Needs to be a 5 by 5. So did you notice I moved it over here so I have the space to do my 5 by 5? Okay. I have the space to do my 5 by 5. All right, so I'm going to change the number for the figure to be a 5. How many tiles would be in my figure? I could change that because I know, right? How many tiles would be in my figure? 5 by 5 plus 3 more, right? So how many would be in my figure? 5 by 5 plus 3 more. What's 5 by 5 plus 3 more, guys? Come on. What are we changing this to? I'm not worrying about drawing it yet. Don't worry about drawing it yet. Tell me what is 5 by 5 plus 3 more, please, so we can get our figure quantity. 28. Thank you. Okay, then we're going to go build this corner, okay? And I happen to be one of those people that it really bugs me that it's not perfect. So if I don't go fast, it doesn't turn out okay for me. So I'm just going to go fast. And if they work, they work. And if they don't, they don't. And I'm not going to stress about it. I just want 5 by 5, okay? And I know some of you feel me about this not having it be perfect looking. But that's why I wish we were on graph paper. I wish they'd given us graph paper, but they didn't, because we could have made it look better if we were just highlighting in graph squares, right? But I'm not going to stress about it. Just as long as what we want there is there. 5 by 5. All right. And I am going to go fix this one little thing because the quantity of this guy got lost in my 5 by 5. So I'm moving him over here. Okay. Are we all good with that? Is there any questions about that? We need to go move these numbers that we did down into here. So figure 1, we said had how many? Figure 1, we said had how many? 4. Figure 2 had 7. Figure 3 had 19. No, 12, you're right. 4 is 19. Sorry. And then 28, right? Now we got to stop and think. Notice they have a figure 0. If we use the same logic, how many tiles would be in figure 0? What would it look like? Use the same logic of what it looks like, what is changing, what is not changing. Keep that in mind and backtrack from figure 1 to it. What is not changing in all of the figures? What do all of the figures have that's not changing? What do all of the figures have that is not changing? The 3 boxes at the bottom. So if all the figures have the 3 boxes at the bottom, then figure 0 must have the 3 boxes at the bottom, right? So at minimum, we would have how many boxes in figure 0? 3. And then we're going to go double check our logic. This box was a 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5. So for figure 0, it would be a 0 by 0, right? So how many tiles are in figure 0? The 3. Yep. That's starting 3. And so we're going to go highlight in our pictures to show that. Okay. The 3 are our figure 0. So they're all going to be highlighted the same color. These are all pinks because they are figure 0. They are figure 0. Okay. Remember, you're doing the highlighting box thing, not the text. Okay. Then we had figure 1 added in this one green box, right? Which means it's the anchor box for all the other ones. Yeah? What did figure 2 add in? What did figure 2 add in? So figure 0 is pink. Figure 1 added on the green. What is figure 2 adding on? The 3 that make this little L, right? Are we okay so far? What did figure 4 add on? I will pick this. What did figure 3 add on? A bigger L, right? So what's going to happen is the box is turning into a rainbow kind of thing, because there were things added each time. Okay, now we got to go to figure 4. What did we add in? So figure 1 added in 1 box, the green. Figure 2 added in 3 boxes. Figure 3 added in 5 boxes. How many did figure 4 add in? How many are we highlighting for figure 4? How many did we add in for figure 4? So figure 0 was the 3. Figure 1 added 1 box in. Figure 2 added 3. Figure 3 added 5. Figure 4 is adding how many? Figure 4 is adding how many? 7. So how many do we expect figure 5 to be adding? Follow the pattern. Figure 1 added 1. Figure 2 added 3. Figure 3 added 5. Figure 4 added 7. So we're thinking figure 5 is adding 9. Okay. Okay, so now we got to go graph these coordinates. So we have to make those into coordinates, right? Our table is coordinates. So let's go make our coordinates. What would our coordinates be? Give me my list. You guys know how to do coordinates from tables. Give me my list. 0, 3. Then go. What's the next one going to be? 1, 4. Keep going. 2, 7. 3, 12. 4, 19. 5, 28. Right? And we're going to go graph it. So I'm going to take this list that I just made and I'll move it down below so that I can graph it and have the list at the same time. So now we've got to look at our scale, right? What are the X and Y standing for? All those things we've done before. What does the X direction stand for on our table? Which one of these is the X and which one's the Y? I think here's my X and here's my Y, right? So what are we going to say down below in words? What does the X stand for? What does the X stand for? Because we have to tell them in words. Figure number. Okay. Figure number. What's the Y stand for? What are we going to tell them it stands for? Number of tiles. Yeah. Okay. So we know the X direction is our figure number. The Y direction is our number of tiles. So we have to look. What is our biggest X? What's our biggest Y? So we can figure out what we're labeling the lines. First, how many lines do we have to work with in each direction? How many lines do we have to work with in each direction? Count how many lines. How many lines do we have to work with? Count how many lines we have to work with, guys. Come on, we were doing really good. There's 15 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we have how many figures on our graph? 1, 2, 3, 4, 5 of them, right? Because 0 is on the line, it's not on the graph. So do I have to use every single line? No. Can I skip and have it count as a 1? Yes. So how many do we want to skip? If we have 5 figures and we have 15 lines to work with, what do we want to skip by? So they don't bump into each other. We could go by 2s, but how many of the lines would we use up? Okay. If I go line 1, line 2, line 3, line 4, line 5, that means my graph only goes here, right? Only goes to this much. But we want to use the whole space, the whole space. So we have 5 figures and 15 lines. So how many lines are we going to be using? 0, and then skip how many to get to number 1? Yes. Because we want them spread apart. Oh, it's in the square now. 1 second. Okay. We want to give them space when we can. Okay. We don't want our graph to be teeny tiny. We want to utilize our space. And since 15 divides evenly by 5, 3 of them, right? I'm going to go and make 5 dashes, but there's skipping. So 1, 2, 3, 4, 5. And I utilize all my lines, right? But I have to tell the people that this is 5, that each line stands for 5. All right. Now we have to go the Y direction. What's our biggest Y? What's our biggest Y? 28. And we have how many lines to work with? 15. So can we go by ones? No. What would a good one to go by? 2s. Yeah. Because most of these, every other one's even, so we're going to have to go between, but that's not a big deal, right? So we're going to go get our lines. We have to use all of them. 2, 4, right? Keep counting as you draw your line. Tell me what you hit when you get to the top. Because each one's counting by 2s, so you're counting by 2s as you draw your line. So where did we hit when we got to the top? Yep, 30, because we were counting by 2s. 2, 4, 6, 8, 10, 12, yeah, and it get to 30 when we got our last line in there. Okay, so we go over to our paintbrush and we make sure it's a 4, and we pick either red or blue, and we have to put these coordinates on. 0, 3 means I go up 3, but each line is worth how much when I go up? When I go up, each line is worth 2. So where would 3 be? 2, halfway between would be 3, right? So every other one is going to be a between, okay? Then I went 1, and I go 4, and I go 2, and I go 7. So I'm 4, 6, 7. And I have 3, and it's 12. So 7, 8, 10, 12. Remember, going up, we're going up by 2s. And then 4, that was 12, 14, 16, 18, 19. So don't keep restarting from the bottom. Use the one you're at. I know I'm at 19 here. I go over. I know 28 is 2 below 30, and 30 was my top. All right. Will I connect these with a line? Will I connect these with a line? Am I supposed to connect these with a line? No. Why not? What does connecting with a line mean again? It's been a while. It's not a curvy line either. We won't connect these at all. We don't connect these dots. Why? What did connecting mean? What did connecting mean? If we connect, that means we're allowed to have part of. Can we have part of a tile? Can we have part of a figure? Remember, we can't connect these tile ones. They're discrete. That's the official word for it, discrete. And they're called discrete because we can only use 1 or 2 or 3. We can't have the parts in between. And we can't have the parts in between because you can't have part of a figure or part of a tile. You can't have part of a human being or part of a car. So there are times when we don't connect the dots at all because you can't have part of it. Remember, we talked about that before. Okay, so these are done. Please turn those in. Let's look at the homework assignment. Let's see. Let me stop sharing for a moment.